Okay guys, this is section 3.2, properties of parallel lines. Go ahead and, of course, you can pause the video if you need to, but I'd like you to go ahead and draw these crisscrossing lines. Just so you know, the arrows right here and here mean that these lines are parallel. The symbol for parallel is that one. So draw this. We've got 1, 2, 3, 4 at one vertex, 5, 6, 7, 8 at the other. All right, of course, we have some relationships here. I mentioned this before. We learned 4 different angle types. We learned about corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. And there are special relationships between those angle types if lines are parallel and cut by a transversal. So we're going to go over those now. Postulate 3.1. Postulate is something that's assumed to be true. It says if 2 parallel lines are cut by a transversal, so here are my 2 parallel lines, here's my transversal, then same side interior angles are supplementary. For example, measure of angle 3 plus measure of angle 5 will equal 180 because they are same side interior angles. They're on the same side of the transversal right here, and they are in between or interior to the 2 parallel lines. Also, we have measure of angle 4 plus measure of angle 6 equals 180. So those are 2 statements that are true based on that postulate, if the lines are parallel. All right, theorem 3.1, it says the alternate interior angles theorem. It says if 2 parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So alternate interior angles would be angles like 5 and 4, they are congruent, or 3 and 6, they would also be congruent. You can kind of tell from the picture. When you look at the picture, I mean, if they fall in the category of either being congruent or being supplementary, you can tell that 3 and 6 and 4 and 5 are more likely to be congruent than supplementary, whereas 3 is an acute angle, 5 is an obtuse angle. 3 and 5 together add up to 180. Okay, we're going to prove this theorem here. We're going to prove that 2 is congruent to 3 in the following picture here. It says, given that A is parallel to B, prove angle 2 is congruent to angle 3. So there's a little bit of a proof. Go ahead and pause the video if you need to write this in. I do have the notes on Google Classroom. I'm under the notes and templates heading, and so you could print them out if you'd like. I notice a lot of you are. It's always an option. It says given A is parallel to B. So we're given that A is parallel to B. We're going to prove that angle 2 is congruent to angle 3, and those are alternate interior angles. So we start with A parallel to B, that's a given. And we move on to the second step, measure of angle 1 plus measure of angle 2 equal 180 because they are a linear pair. You could also write that they're supplementary, but they're supplementary because they are a linear pair. Measure of angle 1 plus measure of angle 3 is also 180, and that's because they are by the same side interior angle postulate, but they are same side interior angles. So since the lines are parallel, the same side interior angles are supplementary. That's same side interior angles postulate. Excuse me. Now we have 2 expressions here and here. They are both equal to 180. That means we can set them equal to each other by the transitive property. If I subtract off angle 1, measure of angle 1 from each side, I get the statement measure of angle 2 equals measure of angle 3. That's the subtraction property of equality. And then the definition of congruence says if the measures of the angles are equal, so if each of the measures were, say, 50 degrees, then their size would be congruent. So we'd say angle 2 is congruent to angle 3. So that's a proof of the theorem that says if you have two parallel lines cut by a transversal, the alternate interior angles 2 and 3 are always congruent. Since we did that kind of in a generic way, that would mean it's always true for any parallel lines cut by a transversal, the alternate interior angles will always be congruent. Right, corresponding angles theorem, we're going to prove this one as well. It says if two parallel lines are cut by a transversal, then corresponding angles are congruent. Corresponding angles would be angles like 2 and 6. They are in this top right position around their vertex. So we're going to go ahead and prove that 2 and 6 have to be congruent given only that the lines are parallel. This will go similar to the last proof. It's pretty similar. We start by copying down the given statement that A is parallel to B. That's given. We have measure of angle 2 plus measure of angle 3 equals 180. That's because they are a linear pair. We have measure of angle 3 plus measure of angle 6 equal 180. That's same as last time because of the same side interior angle postulate. You guys are welcome to abbreviate as long as I can tell what the word is with your abbreviation. Because of these two expressions, we have a measure of angle 2 plus measure of angle 3 equals 180, and measure of angle 3 plus measure of angle 6 equals 180. We're going to set them equal to each other. So we've got measure of angle 2 plus measure of angle 3 equals measure of angle 3 plus measure of angle 6. Transitive property of equality. Then if I subtract off measure of angle 3 from each side, this one and this one, I have measure of angle 2 equals measure of angle 6. That's subtraction property of equality. And then the last step is to say angle 2 has to be congruent to angle 6 by definition of congruence. So that's proving that the corresponding angles are always congruent if the lines are parallel, cut by a transversal. So that's the third one. So we've looked at same side interior angles. That was just a postulate, something assumed to be true. We've looked at the alternate interior angles theorem that says if two lines are parallel, cut by a transversal, the alternate interior angles are always congruent. And then this is the corresponding angles theorem that says if two lines are cut by a transversal such that they are parallel, the corresponding angles are always congruent. Final one here. Alternate exterior angles. So if two lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Once again, we're given that A is parallel to B. This time we're going to prove that angle 1 is congruent to angle 7. Those are on alternate sides of the transversal, and they are exterior to the parallel lines. Here's the transversal that they are on alternate sides of. So starting with statement 1, A is parallel to B. That is given. Angle 1 congruent to angle 5. Why is that? Well, if lines are parallel, then the corresponding angles are congruent. We call that the corresponding angles theorem. And then we have angle 5 congruent to angle 7. That is the vertical angles theorem. Number 4, we have two things congruent to the same thing. That is 1 and 7. So angle 1 is congruent to angle 7, and that is by the transitive property of congruence. Transitive property of congruence. So 3 different angle types are congruent if lines are parallel. It's corresponding angles, alternate interior, and alternate exterior. So both the alternate ones and the corresponding one. Sample problem of how something we would be asked to do is just to find all the missing angles. So you have some angle problems here. If measure of angle 5 equals 65 degrees, we know by the vertical angles theorems, angle 6 is 65 degrees as well. Because of the corresponding angles theorem, we know that angle 8 has to be 65 degrees. I know that angle 8 and 9 add up to 180 because they make a linear pair, so 9 would be 115 degrees. And I know that angles 9 here and angle 7 here are alternate exterior angles, and alternate exterior angles are always congruent, so angle 7 would be 115 degrees. So you can use these postulates and theorems combined with linear pairs and vertical angles to find the missing angle measurements when the lines are parallel. Notice the lines are parallel here and here. All right, it's a little practice one here. Let's do some of this. So this says A is congruent to C. A is congruent to C. So here's our picture. So is A congruent to C? We're going to, it's like a matching them up. So is A congruent to C? A and C are corresponding angles, right? So we're looking for the theorem that says corresponding angles. Let's go check it here. Yes, that's true. So A is congruent to C because the lines are parallel. Notice the markings here. Lines are parallel, so those corresponding angles, A and C, have to be congruent. All right, if the lines are parallel, are F and E congruent? F and E, well, what kind of angles are F and E is the question. So F and E are alternate interior angles, and our theorem says if 2 lines are cut by a transversal, then alternate interior angles are congruent. Measure of angle B equals measure of angle D. So here's B, and here's D. Is that true? Well, just looking at the picture, the parallel lines, it looks like B is an obtuse angle, D is an acute angle. So I'm thinking there's no way they're going to be congruent. They don't fit into one of the categories of alternate interior, alternate exterior, nor corresponding angles. So this one is in fact false. Angle G supplementary to angle E. G supplementary to E. Those are same side interior angles, so that is yes. Measure of angle H equal to measure of angle E. Hey, those are vertical angles. H and E are vertical angles. That's the vertical angles theorem. Measure of angle B plus measure of angle A equals 180. B plus A. Here, let's got B there. Erase these. We've got measure of angle B, measure of angle A. Yeah, that's a linear pair. That's by definition. So that is true. And then angle D is congruent to angle F. D and F. What kind of angles are D and F? Just look at them here. F and D, well, they are alternate. They are not alternate interior, nor are they alternate exterior. They don't look like they're congruent to me. One is obtuse. That's F, and then the other is acute up there. So let's see what happens. There we go. So those are the types of problems you'll be asked to do, applying those theorems. Hope this helps. Thanks for watching.